SpaceX has successfully launched for astronauts to the International Space Station, ISS, for a 6-month mission. The crew, consisting of NASA's Matthew Dominic, Michael Barratt, and Jeanette Epps, along with Russia's Alexander Grebenkin, embarked on their journey from Kennedy Space Center aboard SpaceX's Falcon rocket. Their arrival at the ISS is expected on Tuesday, where they will take over from the current crew comprising members from the United States, Denmark, Japan, and Russia, who have been on the station since August. The launch faced some delays due to high winds, prompting playful banter from Space Station Commander Andreas Mogensen, who eagerly awaited their arrival. Despite a minor hiccup with a crack in the seal of the SpaceX capsule's hatch, deemed safe for the mission, the launch proceeded smoothly. During their 6-month stay, the new crew will oversee the arrival of 2 new rocket ships ordered by NASA. Boeing's Starliner capsule, carrying test pilots, is scheduled to arrive in late April, followed by Sierra Space's Dream Chaser, a cargo delivery vehicle, a month or 2 later. Jeanette Epps, originally assigned to Boeing's Starliner, expressed her excitement upon reaching orbit, referencing the Billy Joel song, New York State of Mind. Epps, the second black woman assigned to a long-term station mission, sees herself as a role model for black girls, emphasizing that spaceflight is an option for everyone. Joining Epps on her first space mission are Matthew Dominic, a Navy pilot, and Alexander Grebenkin, a former Russian military officer. Michael Barratt, a doctor on his 3rd mission, is the oldest full-time astronaut to fly in space, turning 65 in April. Despite his age, Barratt remains enthusiastic about the journey, likening it to a roller coaster ride with a bunch of really excited teenagers. Meanwhile, flight controllers are monitoring a growing cabin leak on the Russian side of the space station. Although the leak has doubled in size in recent weeks, NASA assures that it does not impact station operations or crew safety. NASA has surprised many by releasing its first official tabletop role-playing game campaign, titled The Lost Universe. This unexpected offering comes from the typically serious engineers and scientists at NASA's Goddard Space Flight Center, showcasing a fun and imaginative adventure set in a cosmic mystery involving the Hubble Space Telescope. The game invites players to embark on a journey to uncover the disappearance of researchers in the city of Alderstrom on the rogue planet of Ixlaris, along with the mysterious vanishing of the Hubble Space Telescope from Earth's timeline. Players are tasked with assembling a daring crew of adventurers to tackle this enigma. Designed for a party of 4 to 7 characters ranging from level 7 to 10. The adventure is flexible and can be adapted to various tabletop role-playing game systems. Players are encouraged to use their science skills while navigating challenges and exploring the universe. This unique blend of traditional tabletop role-playing mechanics, such as those found in Dungeons & Dragons, with an engaging narrative involving space exploration, features elements like a technology-stealing dragon and a planet affected by black holes. Crafted in collaboration with NASA's Goddard Space Flight Center, the game was developed by video producer Christina Mitchell and graphic designer Michelle Belleville, in partnership with the Hubble Space Telescope team and Earth Science Outreach. The Lost Universe provides 44 pages of gameplay instructions and includes a medieval-style map of Alderstrom, all available for free download on NASA's website. This educational sci-fi fantasy adventure aims to engage players while imparting knowledge about space exploration and science. Stunning pictures taken by the Very Large Telescope, VLT, in Chile offer unique glimpses into the formation of planets around young stars. These images depict emerging planetary systems that resemble miniature galaxies rather than typical debris disks. They reveal clear spiral arms emerging from dense dust, while others show less distinct clouds of glowing material. For astronomers, these images provide an exceptional opportunity to explore the process of planet formation. Captured by one of the most powerful telescopes globally, this extensive collection includes images of over 80 young stars and their planet-forming disks. Christian Jinsky, a lecturer at the University of Galway in Ireland and the lead author of 3 papers detailing these observations, describes this as a significant shift in their field of study. They've moved from intensely studying individual star systems to gaining a broad overview of entire star-forming regions. These young stars and their potential planets come from three primary star-forming areas in the Milky Way galaxy. Some reside in the Taurus or Chameleon eye gas clouds, both around 600 light-years from Earth, while others come from the slightly more distant Orion gas cloud, about 1,600 light-years away. The researchers discovered a diverse range of planet-forming disks with notable variations depending on their origin. In the Orion cloud, for example, they observed clusters of 2 or more stars surrounded by faint planet-forming disks. Some of the largest stars in the region had irregularly shaped disks, hinting at the presence of massive planets distorting them with their gravitational forces. Jinsky noted that some disks displayed prominent spiral arms, likely influenced by the movements of orbiting planets, while others featured rings and large cavities, likely sculpted by forming planets. Some disks appeared smooth and inactive. Since the 1990s, over 5,000 exoplanets have been discovered orbiting stars beyond our solar system. However, many of these planetary systems look vastly different from ours, leaving astronomers puzzled about the factors influencing planet formation. Observing these processes is challenging due to the distance and dust-obscuring star-forming regions. To capture these latest images, astronomers utilized the VLT spectropolarimetric high-contrast exoplanet research instrument, SPHERE, equipped with powerful adaptive optics to correct for atmospheric blurring and produce sharper images. This enabled them to image stars half as massive as the Sun, a feat not achievable with most other instruments. Additional data from the VLT spectrograph X-shooter and the Atacama Large Millimeter Submillimeter Array provided insights into the star's masses and the surrounding dust. Looking ahead, the researchers anticipate that the forthcoming extremely large telescope in Chile will provide even more detailed images, potentially revealing small, rocky planets within the inner regions of these emerging planetary systems. NASA has decided to terminate a high-priced satellite servicing mission named OSAM-1 due to exceeding costs and prolonged delays. The mission aimed to demonstrate on-orbit servicing capabilities, including refueling the Landsat 7 Earth observation satellite using a robotic arm and other tools. Additionally, OSAM-1 was set to carry the Space Infrastructure Dexterous Robot (SPIDER) payload, featuring a 16-foot robotic arm to assemble an antenna while in space. The cancellation, announced on March 1, follows an extensive independent review revealing ongoing technical, financial, and scheduling issues. NASA cited a shift in the broader community away from refueling unprepared spacecraft as one reason for discontinuing the mission. In response to the cancellation, NASA plans to execute an organized shutdown, which includes handling sensitive hardware, exploring potential partnerships or alternative uses for the equipment, and licensing relevant technological advancements. The mission faced significant cost overruns and delays, with initial estimates of $626 million to $753 million, skyrocketing to over $2 billion by October 2023, as reported by NASA's Office of Inspector General. NASA leadership is evaluating strategies to mitigate the impact of the cancellation on the workforce at the agency's Goddard Space Flight Center in Greenbelt, Maryland. Despite the setback, numerous companies are actively developing satellite servicing technologies, such as integrating refueling ports directly into satellite designs, simplifying the process of refueling. In contrast, OSAM-1 was designed to refuel a satellite not initially equipped for such operations. NASA's Voyager-1 spacecraft, a marvel of engineering launched in 1977, is now over 15 billion miles away from Earth, pushing beyond the solar system's bounds. Despite its remarkable journey, Voyager-1 is experiencing communication difficulties, sending back messages that appear garbled and nonsensical since mid-November. Suzanne Dodd, the project manager for Voyager's interstellar mission, describes the situation as serious. Instead of transmitting coherent data, the spacecraft is sending back a series of alternating ones and zeros, indicating a malfunction in its onboard computer. Despite attempts to reset the system, Voyager-1 remains unresponsive to conventional troubleshooting methods. To address the issue, Dodd's team is delving into archival documents and consulting original developers to understand the spacecraft's design and identify potential solutions. Linda Spilker, the Voyager missions project scientist, describes the team's efforts as a creative and challenging endeavor, requiring a deep dive into 1960s and 1970s technology. However, resolving Voyager-1's current predicament is a meticulous process that could take weeks or months. With communication delays of almost a day each way due to the spacecraft's distance, the troubleshooting process becomes even more laborious. The disruption in Voyager-1's operations is disappointing for researchers like Stella Rocker, who rely on the spacecraft to gather crucial data about the interstellar environment. Voyager-1's unique position allows it to sample cosmic elements such as gas, dust, and cosmic rays, providing invaluable insights into space beyond the solar system. Despite the challenges, there's a sense of urgency to rectify the situation. Voyager-1's power supply, fueled by plutonium, is finite and expected to deplete within a couple of years. Mission managers are implementing measures to conserve power, but the eventual shutdown of scientific instruments is inevitable. Once the power supply is exhausted, Voyager-1, along with its twin Voyager-2, will drift into the void of space as inactive relics of humanity's exploration. While their scientific missions may conclude, the spacecraft will continue their journey, carrying golden records containing greetings and sounds from Earth, serving as lasting symbols of human curiosity and endeavor. Looking ahead, scientists are contemplating new missions that could venture even farther into interstellar space, building upon the legacy of the Voyager probes and pushing the boundaries of human exploration. Despite uncertainties, the spirit of discovery propels humanity's quest to explore the cosmos, ensuring that the legacy of Voyager-1 and its counterparts endures beyond the limits of our solar system. SpaceX is gearing up for its third Starship test flight with an array of new maneuvers and experiments. This upcoming mission, potentially launching on March 14, will diverge significantly from its predecessors, boasting a series of ambitious objectives for the towering 122-meter Starship. The goals set for this flight include a series of groundbreaking tasks such as the operation of Starship's payload door, a demonstration of propellant transfer during the upper stage coast phase, the inaugural ignition of a Raptor engine in space, and a meticulously controlled reentry of the Starship vehicle. To date, Starship has undergone 2 test flights, both originating from SpaceX's Starbase facility in South Texas. Despite the initial aims of sending the upper stage on a trajectory around Earth with a splashdown near Hawaii, both attempts encountered setbacks. The maiden flight in April 2023 faced issues with stage separation, leading to the intentional destruction of the vehicle shortly after liftoff. The subsequent flight in November 2023 saw improved performance, with successful stage separation and nominal engine burns. However, an explosion occurred in the upper stage during a liquid oxygen venting, a scenario unlikely to happen in operational flights, as clarified by SpaceX CEO Elon Musk.